Here's 2.4 on complex numbers. Here's a definition of an imaginary number. When you see a radical with a negative in the radicand, we want you to reduce it by replacing that with an I out in front. So if I give you, let's say, square root of -5, you wouldn't leave that as your final answer. You would replace it with an I in front and then the square root of 5. So that's what I'm talking about when you see the letter I. Another thing, when you have an I squared, so I times I, that replaces as square root of -1, square root of -1. If you group that back together, you would get the square root of -1 squared, which they undo each other, so you're going to get -1. So the rule is, if you see an I squared, replace it with -1. If you see a radical with a negative, remove the negative and throw an I out in front of that radical. Do you remember that from Algebra 2? These are imaginary numbers, complex numbers. Give you a little time to write that down. And then there are higher order powers of imaginary numbers. And what happens is they start to repeat a pattern. And the pattern are the first 4 in the red. I raised to the 0 power, so anything raised to the 0 power is 1. Then I to the 1 power, remember, I represents the square root of -1. Well, that's still just I. Then I squared is I times I, or -1. And then I cubed is -I. The reason why is you can replace this I squared with a negative, and then you have I. And then after that, the pattern just repeats. Every 4 powers, it repeats that pattern over and over and over again. So if I asked you for I to the 4th, that represents I squared times I squared, or -1 times -1, which is 1. Or look up in the pattern. It comes back as a 1. Then what would be I to the 5th? I. And then I to the 6th is -1. I to the 7th, -I, and now it repeats the pattern again. One. Here's a little question for you. If I give you I to the 16th, you could continue repeating that pattern over and over again, or you can break down 16. There's 16 I's going on, so you could rewrite it as I to the 4th times I to the 4th times I to the 4th, so now I have 12 of them, and then I need one more set of 4. So what are all those I to the 4ths? They're all 1s. So I have 1 times 1 times 1 times 1, which is 1. It's another way to use your patterns. Okay, let's go on to these. Now we're going to go ahead and simplify these radicals. All of these radicals are not properly reduced because they have negatives in the radicals. So we want to reduce the square root of negative 15. So what would be the answer there? What would you do with that one? How would you leave it as your final answer? I square root of 15. And then I would look inside of the radical and I'd say, can I break down 15? Well, I could do 3 times 5 is 15. Doesn't help me at all. So my final answer is in reduced form. If I go on to question B, how can I reduce that? Can I do this? I square root of 16 and then leave that alone? No. Square root of 16 is 4. Or rewrite 16 as 4 times 4, and then you're pulling off that 4. So your final answer in this one is 4i. Because square root of 16 is 4. Question C. How can I reduce question C? Two, pull out the I, and then I'm going to break down 18 into what product of what two numbers will be the best choice. 2 and 9, yep. And then the square root of 9 is 3. And then multiply like parts. 2 times 3 is 6i. And then my leftover is square root of 2. All right, let's go on to standard form of complex numbers. Standard form of a complex number has a real part and then an imaginary part. The blue is your real part, and then your red is your imaginary part of a complex number. And what we're going to do is we're going to add, subtract, multiply, and divide with complex numbers. So I have some examples for us. And those of you who had me last try were able to go out and view your quiz score for 2-1 to 2-3 and your final grade online. They're out there. Okay, let's do these two examples. So we have two complex numbers adding together. One complex number is 4 plus 5i, and the other complex number is 2 minus 3i. So how we combine these together is we combine real parts to real parts and imaginary parts to imaginary parts. So my real parts are 4 and 2. So I'm just going to kind of put them next to each other. And then I have my imaginary parts, 5i and negative 3i. And now I combine those terms. So 4 plus 2 is 6. And then 5i minus 3i is 2i. Now I have a new complex number in standard form. We want the real part first, then the imaginary. Yes, ma'am. Thank you. We'll finish this question B and then I'll stop the timer. All right, question B. Now we're going to subtract these two complex numbers, but we also have a multiplier in front of that parenthesis. So we have to first multiply these two terms by -4. So I'm going to leave the first complex number alone. That's 3 plus 2i. And then I'm going to distribute -4 through. -4 times 1 is -4. And then -4 times -5i is negative is a positive, and then I. Now I'm going to combine the real parts together. 3 minus 4 is -1, and then 2i plus 20i is 22i. I'm going to stop the recording there.